What's up YouTube? It's time for another React tree fiber project, and the one that I have today is really interesting. I had this idea in mind where I wanted to create in Blender a floating island with a portal and a bunch of awesome effects, and the end result is the scene that I'm showing you now. There's lots going on here, starting as I mentioned with the floating island, all the rocks that sits behind it. They're all using the same motion animation, which is incredibly easy to set up with React tree fiber. But we also have 3D text, some particles that are made with the sparkles component, but the real star of the show is probably the portal that sits at the center of the scene. You'll notice that if I move my camera around, whatever is visible through the portal gets updated depending on the camera position and direction. We also have a lot of post-processing effects, and of those, the one that is definitely most interesting is GodRays. Look at that. I always loved them when I saw them in games, and as soon as I found out that there was an easy-to-use exporter for React tree fiber, I couldn't resist and I had to use it for this project. As always, I'll try to break this down in a few short videos and make the entire process as digestible and concise as I possibly can. And yeah, there's a lot to cover, so let's dive right in. I'll leave two links in the description of the video, one for the GitHub repo of the project and another one for you to try live on your browser. And the first thing that we need to do to get started is to get our dependencies. I'll run these 4 commands in my VS Code terminal, one after the other, and you'll notice that I'm saving the exact version of the libraries that I'm downloading. That's necessary because things move somewhat quickly in this space and I want to make sure that we all have the same environment. Okay, I'm done downloading my dependencies, and this is the file structure that Create React app automatically makes for you. I'll start by removing everything from the source folder, and then inside the public folder, I'll just leave index.html and delete everything else. And now inside the source folder, I've made 3 files, index.js, super simple setup for React 18. We have index.css, which is just making sure that the canvas will be full screen, and app.jsx, which is importing a scene container that doesn't exist yet, and it's wrapped by the canvas component from React tree fiber. All the fun stuff happens inside the scene container though, and this is where we're going to put most of the Three.js objects that we're going to create throughout this project. I'm starting with a suspense block for all the 3D assets that we're going to download later, and then I'm using the environment primitive from React tree drei. This component will start by trying to download 2 files that I'm placing inside the texture folder. You can find a link to both textures in the description of the video, and you can imagine the environment component as a 3D background for your scene, which can also affect the lighting of all the objects that are inside of it. Normally you would have a single environment map that affects the lighting of your objects and is also used as a background. In this case though, I'm using 2. One that is only going to be used as a background, and another one that is only going to be used as a way to change the lighting of the objects. And the background property in this case is the one that determines which one of the 2 is treated as the lighting environment and which one is treated as the background environment. Next we have a simple perspective camera that is placed 10 units high from the center of the scene, and also our usual orbit controls component. This component makes it possible for us to move around our camera while orbiting around a specific point that is defined with the target property. In this case, our camera is orbiting around a point that is 5 units high in space and 1 unit to the right. Now we can finally test our setup by running npm run start inside our VS Code terminal, and if all went well, a new page will pop up where we'll be able to move our camera around, and the only thing that we're going to see for now is just a blurred environment map. We're now ready to download some models. You can find them in the repo of the project, and as always I'll put the link in the description of the video. Next up is the floating island component, and I'll walk you through what I'm doing here, but it's really simple. I'm using the useLoader hook to download a gltf scene that I've made in Blender, and as soon as it's available, I'm referencing the only mesh that is being exported from the scene. And then I want to apply a light map to this material. So the original lighting information of this mesh has been baked in Blender, and to recreate the same baked look, I have to apply a light map to the material. But to be able to do so, I need a new set of UVs on the mesh, which I'm creating with these 2 lines. Basically, there are some textures in Three.js materials that require a second set of UVs, and light map is one of those. These 2 properties will affect the look of the light map. The first one will increase its intensity, and the second one can tint the base color of the texture. Lastly, to inject an already existing Three.js object inside React tree fiber's scene graph, we can use the primitive component. This is how you would normally make a mesh in React tree fiber. You would reference the mesh component and have a geometry and a material contained inside of it. But in this case, since our Three.js model was created externally by useloader, we have to reference it inside the React tree fiber scene graph by using the primitive component. For completeness, I'll mention the primitives will not dispose of the object they carry on a mount. We are responsible for disposing it. So all of this means that to release the resources the Three.js allocates to this object, we would have to call the dispose method on our mesh object whenever we unmount from the component. But we don't really have to care about it for our simple project because the mesh that we are injecting in the scene will never leave the scene, so we don't have to deal with this. Now we can import our floating island in the scene container, and there we have it. I didn't realize how bad this looks without the other components, but hey, I don't know how to model stuff in Blender. It's already a miracle that I got this thing to work. We're now adding some rocks with the same exact method that I've described for the floating island. And I'm also creating a simplified version of the portal component. In this case, I am creating and injecting two meshes. One will be the actual portal and another one will be used to create the cool portal effect that we saw in the introduction of the video. And as soon as we have the models, we can edit some of the properties of their material. Oh, and by the way, when I'm using this signature, model.scene.first item of their children array, what I'm essentially doing is getting the first mesh that is being exported by the gltf scene. And that's because in Blender, I have made a single object for this scene that is like the only mesh that is being exported in the gltf scene that I've created. So basically this is a way of getting the only mesh that exists inside this gltf model. And as soon as I get that, I want to increase the environment map intensity, which is a property that controls how strong the background lighting effect is in this material. And the mask mesh is a simple quad that we want to be visible from both sides. By default in Three.js, if a triangle is back facing the camera, it's not going to be visible. But by using the double side property for their material, both the front facing part and the back facing part of a triangle will be visible. So far so good, and the next step will be to add the free floating rocks that were part of the original scene. We'll add one last component to our scene before we finish off this first part of the series, and that's the floating rocks. We're using useloader again for free meshes that we're loading with the primitive component. The only thing that we're doing different this time is that we're also specifying the position of each individual mesh. We can then import the floating rocks in our scene and we're good to go. And I think we're ready to wrap things up for this episode. Next one will focus on some of the remaining elements of the original scene, and we're also going to set things up in motion. Having said that, thank you so much for watching and I hope to see you again on our next video. And until then, cheers!